Hi everyone, again welcome to this lecture. Today we will be continuing the Linux networking topics. This is lecture number 4. We finished the Linux basics and now we are into Linux networking. Today we will be talking about the domain name system. This is one of the important things that we really touched upon during the first lecture, and then now we will be taking it up in much more details. So before I go into the this domain name system itself, let's recap what we learned the last lecture, the lecture number 3, which was mainly about the file transfer protocol, or FTP. We learned about how to do the FTP itself by using the FTP and then followed by the FTP server command. And then there are various commands that we used to transfer files back and forth. You can transfer it into the FTP server, and also you can get the file into your system. And there are various modes by which you can transfer. All those things we learned. And then we also learned something that is unique, which is how to set up an FTP system or FTP site in your machine. Specifically we learned about the FTP access.control or CTL. This particular file resides in the /etc area, and this is the main file that is used to provide access to any users. And here we use several keywords: access, deny, read only, write only, things like that, to make sure that whoever is connecting to do any kind of FTP activity has all the permissions he or she needs to do the file transfers. Then we also learned some administrative commands like FTP who, FTP count, the ping command that we already know about, things like that, to see how we can transfer effectively. So I hope it was interesting for you all. And now let's look at some activities that I want you to do based on the last lecture. So go ahead and actually answer these questions. What do these commands do in FTP? Bin, LCD, mput. So I think like these are the commands that we already learned in the last class. So it should be fairly easy for you to answer these questions. The second one is slightly more challenging. Is what commands will you use to set up an anonymous FTP? Essentially, like this is I'm clearly referring to the FTP access.control. Inside that, what do you write to set up the anonymous FTP? Some hints I can give you: when you talk about an anonymous FTP, you don't know who is actually connecting, so you need to make sure that you need to give all the permissions that is needed for any kind of access. So yes, it depends on what they want to access, but I also want you to give some idea as to how you want to give this the permissions. And then the other question, this is fairly simple, is where will you set up the FTP access.control? This answer is, I think, like it's in the previous slide, so if you just refer back, immediately you'll get it. So again, this question is slightly difficult than the first one. The first one is helps you to get the basic understanding, and this one slightly more. And then if you are still like if you are looking for more challenge for you, it's the third question, which is find the number of connections that are available for each FTP server configuration in your machine. So your machine has like several configuration of FTP. Find the number of connections that are available for each of those configurations, who are connected to those various FTP servers. I think like this is fairly easy assignment. Just you should be able to do it in no time. if you were paying attention to the lecture 3. So now we will start today's lecture. Today's lecture is on domain name system, as I mentioned. So let's look at the domain name system. Here we will be learning about configuring the domain name system name resolution. We will also try to configure the dial-up network using the PPP or the point-to-point protocol, and then we will also try to understand the client services such as DHCP and LDAP. These are all like acronyms that we will study later. Then we will also like look at some of the graphical applications and remote dial-up authentications, and then we will also look at some client level tools such as web browsers and email clients, because these are kind of you can almost think of them as applications of the DNS name resolution system. So first of all, what is DNS? DNS is a hierarchical distributed naming system for computers, services, or any resources connected to the internet, or even a private network, so that everyone knows what the other computers or services are available and addressable. So address is one of the key things that everyone has to have. You have your home address, and so like I mean in the locality people know like how to get hold of you to come to your house, and they also know your name, so they can actually approach you, and then they know that it is you. So it is kind of, it gives the identity of a person. Similarly, the domain name service and domain name system, you can think of it as a directory where we store the identities of all the people. And the key thing is, I think like we saw a little bit in the last one. Like I mean, as you know, the IP addressing that we learned when we learned about IP addressing. IP addresses are this 4 octet numbers which are binary, or maybe you can convert that into decimal or hexadecimal. But the issue is, if I ask you to remember say like 10 IP addresses from different sites, you will soon just not able to recollect or recall any of the numbers. So for humans we need something which can identify what is a web address. For example, google.com, you need to know what like I mean you need to know the IP address in order to go to the google.com, but at the same time what you want to remember is just the google.com and not its IP address. So the domain name system provides a way to actually do this. So let's look at how we do it. So in this course we will be talking about like setting up, but again it's a translation file. That's how you can view it as, where you can think of the numerical IP addresses on one side and then the actual text based domain names on the other side. So and imagine, right, I mean this you can use it to find and locate any computer services and devices worldwide. This is one of the beauty of internet, so that you can really find any computer in any part of the world connected to an internet very quickly using the domain name system. So in fact, as I said, it's an address book or a phone book, you can think of it for the internet. So that's how you should view it as. some domain name like say like example.com, it translates into address 192.0.43.10. So I mean the DNS will just store that that name, essentially that www.example.com along with its IP address, so that if you type in www.example.com, it takes you to that site using the actual IP address, the numerical IP address. So closely associated with the DNS is also the URLs. Essentially, like I mean, that is the names starting with HTTP. So URL stands for the universal uniform resource locators, and essentially that's basically it's a form of the IP addressing, which is which is a part of the DNS itself. So on the domain name syntax, essentially, like I mean, so we will be learning about it. Before that, let's look at the how we do the name resolution. The DNS itself is implemented by a domain name server. The domain name server essentially keeps multiple all the details, the IP addresses of in the world, pretty much in the world, and its corresponding the textual addresses in one place. Here the term domain means the name of the multiple hosts in the internet, and that are collectively referred to. The most widely known the domain name is the .com, and pretty much a lot of people will be lot of you will be working for one of the .coms, and we call it like the .com era, things like that. And an organization can have its own domain or collection of domains. The network hosts, the names of the network hosts are the host name essentially, and the FQDN refers to the fully qualified domain name. It combines the host name with the name of the domain. So we will see some of the examples in the later section. So this is essentially like I mean how you would set up the name resolution. The domain name syntax is one thing is the top level domain is always represented at the rightmost as the rightmost label. So you can almost think of the domain name as an inverted tree structure. So the .com is at the top. Here you can see that the .com is at the top, and then followed by the remaining part in the .com is here, and then you can also have the other items to the left of the .com. So let's look at some of the examples. So here there are multiple examples. The top level domain name with .com. One example is www.ibm.com, which is essentially like I mean COM refers to commercial organization, or to the first three letters. And the other top level domain name is widely used is also .gov or .gov. Here the example is www.state.gov or irs.gov, things like that. the GOV refers to the government, and it's typically the US federal government. Then you have EDU, which is the another very common top level domain name. For example, here it's www.ucla.edu, could be like stanford.edu, several schools.edu, and these are the educational institution. So that's why the first 3 letters again, it's it stands for EDU. Circle the EDU here, COV. Now the military, US military has its own top level domain name. Again, that's denoted by the first 3 letters, MIL. And any kind of organization, whether it's profit or non-profit, mostly it is non-profit, they have their own domain names, and that is the ORG. So it's right here. And then, so these were the primary top level names for long time. Like top level domain names were only like COMS, gov, EDU, MIL, and ORG. Today the US has opened up with other ones like .NET is any networking services. It's not just limited to the networking services. There are many companies now getting the this one. And then .us is another one, which is mostly a geographical domain, and it exists with the other domains in US, and it's also used by a lot of state governments. Even though in the California uses also like a lot of GOV names as well. Then there are country specific names. For example, JP, Japan, IT is Italy, DE stands for the Deutsch or Germany, and I think like you all know what IN stands for. That's the India, and one of the famous domain names in India, within India is airnet.in, which is essentially the educational research network. So that goes to a lot of educational institutions, and you can find those several other names like UK stands for the United Kingdom, AUS I think is for the Australia, things like that. So you should be able to find the top level domain names for a lot of these things. And nowadays, like actually like now they have the particular body that controls this the domain names, they are opening up in a big way. So there are more domain names that are available today. So before we go into the resolver, there is also the hierarchy of domains. As I mentioned, like I mean, when you are reading the domain names, it goes from right to left, with each label specifying one subdivision, and each label is separated by the next label by a full stop or a dot. So we just call it like www.ibm.com is essentially, you can think of it as the com being at the top level, and then under that one of the sub domain is IBM. It could be Intel, could be another subdomain, so that will be again www.intel.com. And then if you want to put more stuff within Intel, say like the semiconductor division or say like microprocessor division, you will say like microprocessor.intel.com. So that means that it's a subdivision under the Intel keyword. And there are some rules governing the names themselves. Each label can go up to 63 characters. The tree of subdivisions may have up to 127 levels. So I mean, I don't think like anybody is using that kind of a thing. but you can think of the deepest tree that can accommodate all these things. So the other rule that also says is the full domain name must not exceed the length of 253 characters in its textual representation. So the internal binary representation of the DNS has a maximum length of 255 octets of storage. But even though, like, I mean, it allows the 255 octets, in practically actually it's much shorter, because the domain registries don't have like a lot of address space that is needed for accommodating this particular IP address. And the domain names themselves can contain any character that can be representable in an octet. So it is not limited to just alphabets and things like that. But typically, basically, it includes the ASCII character set, that is A through Z, digits 0 through 9, and then uppercase A through Z, and also hyphen is also can be accommodated. This particular rule is also known as LDH rule, which is letter, digits, and hyphen. Usually the domain names are interpreted in a case independent manner. So the lowercase IBM and uppercase IBM means the same thing. And the definition of a host name is a domain name that has at least one IP address associated. So the way to convert that IP address is to store the IP address with the corresponding domain names in a text file. As I said, like this is your directory, and this is actually located in the /etc/hosts file, which should be you will be able to find it. So just underlining that /etc/hosts file. There are other files that are also being used, the hosts.conf and nsswitch.conf. They determine the order in which the resolver looks at various sources to resolve the IP address. Again, as I said, the IP address and the whole directory structure is all hierarchical, and sometimes you may not have the storage space to store everything. So you have to look at these additional files to see where is the information, if it goes beyond the hierarchy that is supported within the within your system. Let's look at configuring the DNS resolver. So graphically, here you can see basically the host name, which is Sundance, the domain name, I think xmission.com. Again, you can see that the .com is the top level domain name, followed by the subdomain is xmission, and then you have your host name, and then the primary DNS that you can say what is the domain name system name, and then there is 192.168.100.5 I think by now you know, like, okay, these 4 octets, what they mean, what is a network and what is the actual host ID. And then the same thing like secondary DNS also you can specify. So it's part of like 2 networks, and in one network it is named as the 5th computer or 5th machine or 5th node, and this in the second one it's actually termed as the second node. So here is the webmin utility, which is essentially like used to configure the DNS resolver. This one is again like the configuration page. Essentially, like one of these tabs is what you will click to get the other one, and then configure the DNS resolver that way. So here is how the DNS client itself is configured. Something like this may be like hard to read, but it also gives the same information: the DNS server information, the host name, and then there are I think like that. Those are the main information that is on this side, and that's used to configure this system. But before we go into the next one, which is the dial-up network using the point-to-point protocol, I just wanted to add how the address resolution works. So essentially, like the domain name resolvers determine the appropriate domain name servers responsible for the domain name in question, and it does so by using a sequence of queries, starting from the rightmost or the top level domain name. So a network host is actually configured with some initial cache, essentially, which has some known addresses, and then when you query to the root servers, you get like the authoritative top level domain. Again, I'll just clarify that authoritative server. Authoritative name server is a server that gives the answers that have been like configured by the original source itself. So again, these are all like a self-spawning system. You can almost think of it that way. Initially the domain administrator pretty much codes this the domain names into one of the servers, and then from that point onwards it just spawns, and then basically like it actually provides answers to the next server, and then that pretty much like recursively it goes on and populates all the servers. In fact, if you are doing any kind of web searching, things like that, this is one of the key concepts that was developed, basically, that when one person gets to know something by recursion, everybody else in the network knows about the same thing, and this actually helps in doing a lot of web searches where the material itself, what you're searching on, will be stored, distributed across the network, and whenever you want you can easily get it, because the system can use recursion to gather this information and present it to the top level. So the entire directory is also known as registry. So and then there is also like the main registrars who essentially registers any key or in fact all the IP addresses. So let's look at the point-to-point protocol or PPP. PPP is one of the protocols that is used to connect to internet. via modem. It includes features that that is security, flexibility, and dependability, all of them. Than terminal emulation. So emulation is another way that you can use where pretty much what is in the remote side you emulate it into your machine, and so basically it does what the other thing will do, or kind of mimics what the other thing will do. PPP is essentially more interactive in the sense that whatever the messages that you are sending, basically they are actually sent to the remote system and executed there. So one thing to note is it's not very secure, and used to be like very challenging and challenging to configure and manage. There are two advances that happened that improved the PPP security. One was the password authentication protocol, or PAP, that stores the user data in a file that only the root user can access. Then the second one is which is becoming more and more important, is the challenge handshake authentication protocol, called CHAP. This is most secure PPP option. So one example will be like your RSA, or secure access token mechanism, where it challenges you with either a password or your particular PIN number, and then once you send that PIN number, then it starts it authenticates you. Some variants of this methodology is you have a PIN with a random number generator, and this random number generator is actually synced with the server inside the system or inside the company, and then once you generate a random number based on your PIN, and that's compared against what is generated inside the system, because the algorithms do allow the system to be doing very similar to what you are doing. So once it understands that once the passwords do match, then it provides that handshake is actually carried over, and then that's how the user gets authenticated, and now he can actually do whatever he wants inside the system, because it knows exactly who the person is and his identity has been established. So let's look at how this connection will happen. It's a text mode utility called the WVDial that pretty much works to eliminate all this difficulty in connecting with PPP. And this one you can actually use it from the command line in a server. In Red Hat Linux, there's a utility called RP3 which is provided. This is a wizard driven graphical utility, so it goes through the various steps to make sure that you can set up the PPP connections. In Linux KDE graphical environment, a utility called KPPP is used, and then the dial D is also like used to automate PPP. But dial D is kind of difficult to use and a little bit more challenging to set up. So here is one example of how do we set the PPP connection. So here there are many options. One is the let PPP do all my authentication, begin connection when the computer is turned on. You may or may not want to do that, and then let user start and stop the connection. So this is, I think, like a good option, so that the machine doesn't shut you down when it needs. And then the other one is the make the connection the default route which is also kind of important so that you receive the maximum messages. Then configure the name resolution automatically, which is, I think it's a good thing to do, like when you are configuring the PPP, because once you do the name resolution automatically, then it is going to a primary source and actually getting that information, and then it populates. And as I mentioned, the recursive population will enable that the whole thing is populated in no time. Then there are other options for restarting when a connection dies. Then then one thing to note is essentially, like once you set up a PPP, if it cannot find a connection, it can hang, and you can set up the time to wait for the connection to be complete. Finally, it also provides the way to configure the primary DNS and the secondary DNS server. Then there are some low power features which is also mentioned here, like bringing the link up and down automatically. So with inactivity time set, essentially you can do all these things as well. So here there's more dialog boxes. This is used to set up an account and starting a connection using the KPPP in OpenLinux. So as I mentioned, like there are other PPP servers. This in the Linux KDE graphical environment, this KPPP. So it's using that KPPP to set up an account and start a connection. I think, like, I mean, you're familiar with some of the PPP and the DHCP, because if you have any iPhone or anything, you will be working on this a lot. So just to give you more sense of how this name mapping really works is, so as I mentioned, basically like the network host is initially configured, so it has at least some basic directory and then it builds on the directory. Then you make a query into one of the root servers to find the server authoritative for the top level domain. Then once that is completed, that gives you the server for the next level, because it contains for that particular top level, like .com, what is the next part, which is IBM, and it gives you that the corresponding IP address. And then you essentially, like now you send a query to the server, the address of the server that is returned, and then essentially like that will provide the address of the DNS service DNS server that's authoritative for the second level domain. So now we first went to the first level domain, then that gave us some information. We take that information and then we submit to the second level of domain name, and then now that is going to return something. If that's all you need, you stop it right there. But if you want to continue again, you can go and continue on with other sub levels as well, whatever is available. So one thing that I wanted to add to the slide that we talked about, where there's domain names, this one. So today, like .com and .net domain names, they use the directory the domain registry from VeriSign. VeriSign is the company that keeps these two domains essentially. So they register who is using which domain, how long is supposed to use, and also what are the dates that the things will expire. So just to keep in mind. So let's talk about DHCP. DHCP stands for Dynamic Host Configuration Protocol. We learned a little bit when we talked about the IP addressing. We just started talking about it, but we will continue in that lecture. So as I mentioned, like initially we started with IP addressing the 4 octet, and pretty much like we wanted every machine in the world who is connected to the internet have a unique identifier. But with just these 4 octets, it's just not possible. And not only that, if a machine is connected to a network, then you may want to move that machine to some other place and either replace it with a new machine or not replace it with a new machine. But you need more addresses than what is provided, so that you can be successful in doing this DNS and the other things. And then also, like, you don't make any of the DNS you don't want to make them like obsolete. So the way to do it is this dynamic host configuration protocol, which lets you change the IP addresses at the time of installation or at the time of setting it up. So essentially, like, the DHCP allows the configuration of the service that hands out IP addresses to the network clients. And since, like, you are creating new IP addresses, and essentially, but it's in under the sub domain, so that it does not clash with the main domain. Now you can actually, like, keep updating whatever web address that you want. All you got to do is to make sure that the DHCP server has that information, and it's actually like so better. So advantage of DHCP is it can reduce the administration costs quite a bit. The DHCP server itself is installed by default on many Linux systems, so you don't need to do any kind of thing for the DHCP server. And you can also look at the configuration of your machine in the lab from the /etc/dhcpd.conf file. So how do you use the DHCP? So again, in this section, DHCP, like, we can configure the DHCP graphically, as shown here. This is one of the things where you can actually, like, the IP addresses that you can give. You can give like some pointers to the Verilog and the UPS, and then you can let it run. So now let's look at the LDAP, or lightweight directory access protocol. This provides the directory structure that lets the users query a database of network resource information. So the LDAP directories are organized as inverted trees, and in order to use the directory services, the client software allows the traversal of the tree looking for the needed data. Objects in the same tree are referred to using a formalized set of identifiers. So that's pretty much on the local directory access protocol. Now let's look at how it is organized. So here in the LDAP, you can see that basically there are two different types of objects. One is the container objects, and then the other one is the leaf objects. And it's fairly easy for you to actually select the container objects. You can see that actually the FDR, admin, FDR, and font are the container objects, and then the lower level items, files, and etc. They are the leaf objects essentially. So here let's spend some more time to understand how the LDAP works. So here, like we have a top domain called just called top. Under top we have like Latvia, Italy, and then we have also like another one, Mexico, and there are attributes of these country objects. The attribute will be a class is country, the name is whatever the name of the state or the country, just the name of the place itself, and then there's an internal code, and then also the capital city. So these are the four items from the for this particular LDAP. So like under Mexico you can still have like IBM and Nextel, and in fact you can also have in Italy if you have ties with Italy, and then you progressively go down. Essentially, like then it's the various people, under various people, various groups. For example, here there is a CM named Luis Rodriguez, and another CM is LaserJet, and then the third one is a marketing group itself. And then from there you can still further down, go down the hierarchy. As I mentioned, like you can have like all the 256 levels of logic, and also like everybody is also trained in those kind of things. So now let's look at some more. So how do we run applications remotely? So the way that we run, for example, here, like you can think of the host name. The host computer has just few programs. So here all these Kpaint, Kcal, Kcalc, and Kpaint, these are all just the host program. Whereas actually, like I take it back, only the first two. Only the first two, but then the remaining programs, out of the remaining programs, the GIMP or Kpaint, kcal. They are more like batch programs, or they are actually we want to run it under the this server. So what do you do? So again, the number one requirement is we need to configure the remote host before we can use it. So we need to tell in that computer as to what which clients will be using that resource. So we need to authenticate that the user in the remote system. One way to do it is like, I mean, actually there are several X-host authentication services that are available. A quick one is like the Xhost Plus kind of a thing, where it actually opens up the terminal for receiving any kind of X requests. The Xauth is another one, which is it's more secure than Xhost, since it employs the use of the but I think like Xhost is quite prevalent today. I want you to in fact try some of the Xhost commands and see like how they work. And then for the remote graphical terminals, the XDMCP will get you the remote X service, and it will have a logical login screen or a graphical login screen, and it will be using the X clients. So for remote execution, there are R units that are available. What are R units? We will see in the next slide. But essentially, like things like copying or going to a directory, those kind of things. This R utilities are much more helpful to connect to a remote machine and then perform this operation. And then the UUCP is essentially like, I mean, that's the transferring emails over model between the two mail servers. So the R commands that I mentioned earlier, these are like standard Linux commands. R-who is essentially like a remote who, so it logs in to see like, I mean, who is using what. Then R uptime is the other one, how long the server is up, and then so that it tracks that. R login is a remote login. This everybody should be familiar with, which is essentially a way to get the remote system respond to your request, which is R login. And then RSH is another widely used command. It is essentially it executes a command in the remote computer without logging. And then RCP is the other one, which is copying the files. So it helps in copying. It does not even copy. And then basically it's a very fast discoverer of no, sorry. So RCP is essentially to copy one or more files between two computers. It could be like either a local computer and remote computer, or just between two remote computers. So RCP is another widely used command. So now let's look at some of the mail clients. One of the most famous one is the browser. So the popular Linux browsers are Lynx is one of them, which is a text-based browser, and it comes up free with a lot of Linux machines. Netscape Communicator is still used. Then Mozilla Firefox is another one. This is by far the most common one. Again, Mozilla is again another open source type of graphics. So and then they they work on that. And other browsers are Opera, Dillo, Galleon, Skipstone, etc. Now we go into more details regarding the Linux browsers. Sorry, the Linux browsers. So again, like let's go to this previous slide and then see like, so there are several popular Linux browsers. Lynx is one of them. It's the text-based browser that is installed by default on many popular Linux installations. So let's look at the Lynx browser here. Again, it's the text browsers are kind of, it's a novelty at this point. So we are all used to a lot of this graphical user interface and working with the browser. This text browser is kind of unique. You can think of it. You can see that actually, like, I mean, it kind of types up the stuff and then basically like it goes on. And then the way to interact it is also like, I mean, there are some arrow keys that you can go to, like scrolling up and down. And then you need to provide the address in a particular box and then it displays this. A good thing about these kind of text browsers are, first of all, they are fairly easy to bring up. Secondly, the text browsers are much more faster than the graphics based ones. But nowadays, like, I mean, actually the processor speeds are so much that you don't see any difference. But if you remember, even the Google started as a text based browser, and then actually not a browser but at least a website, and then it basically added various graphics. But even today, actually, like, I mean, the basic Google is just a blank page with just one small window where you can type in and then get the information. So the next topic is going to be the email, but before we go into email, I also wanted to talk about a few things. One is on the security, essentially. So the DNS software needs to consider the security aspects of it. There are some vulnerability issues that were discovered, and they were exploited by some malicious users. There is something called DNS cache poisoning, in which the data is distributed with cache resolvers under the pretense of being an authoritative resolver. So basically, like, I mean, it corrupts the DNS entries, so that if you're typing the google.com, it will take you to some porn site or some other site. It also, like, I mean, once that data gets put in one of the servers, as I mentioned, basically the whole system works in the recursive mode, where now when another system queries about the addresses, suddenly, like, when you get this address, which is also like the corrupted address, and then suddenly the corrupted address just flows through the system. Some of the denial of services also can be used or can be a result of this kind of attack, where you capture the directory of one of the system and then put a fake URL or fake IP address, for a given URL, and then whenever somebody types it in, it takes you to like say like /dev/null, which is like no place. So that's kind of the denial of services attack. Again, it's all results in this whole recursive mechanism. So if we obey and use it properly, we can also like get back the proper results. Otherwise, it's basically we can easily manipulate and destroy the whole thing. So once these kind of attacks started coming, now we are talking about the domain name security extension, domain name system security extension, or DNSSEC for short. These extensions offer some kind of cryptographically signed bits. And then since they are encrypted, and that can prevent some of the attacks essentially. So nowadays, like I mean, there are several extensions that have been devised to make it secure. A simple thing will be like HTTPS, which is a secured HTTP, or the hypertext transfer protocol. They also have like some spoofing effects, whereas so like I mean, this is another way to attack some of the things, where you just change the names slightly. For example, if it is google.com, which is google.com, somebody can spell another site called googel.com, google.com, where if you type that wrongly, suddenly like you end up in a altogether different site, which can do a lot of other things. And this kind of vulnerability is exploited in what is called phishing. Phishing is PHISHING. It is kind of an act of it's an attempt to actually acquiring information such as usernames, passwords, and even credit cards by masquerading as or covering yourself as a trustworthy site, and so that you can get all this information. And phishing, even though like I mean right now it's very popular, like there are several phishing sites and doing all these things. This term phishing itself was described in detail in 1987. So imagine it's been around for a long time. It's now famous because of the internet. So with that, I'm going to conclude for tonight, or for this lecture. We will be talking about understanding the email and continuing from this point in the next lecture. Okay, so thank you very much. Once again, thanks.